if I were to divide the velocity by time, I'll get acceleration. Let's see. You might have heard this word before, acceleration, which we, in normal day-to-day life, we use the word acceleration to represent that something is speeding up. Like if I say the car is accelerating, what I would mean in our day-to-day life is that the car is speeding up. Let's try to understand this concept in a bit more detail. Let's say a car starts its journey and we start like recording its journey at this time, and we say that this is time is equal to 0. So this is when when we start recording the journey of the car or any moving object here. Now so this is here at t equals 0. This is where the car starts moving. So it was stationary at this point. Like it was at rest. It was not moving at this point. So the velocity of the car here is 0. Now I noticed that after 10 seconds, t is equal to 10, the car has sped up and its velocity is now, let's say, 10 meters per second. Okay? Now, you see there is an obvious increase in its velocity or change in velocity at some time, like at the span of some time. So this change in velocity divided by this change in time is your acceleration. What we're essentially looking at is how much velocity has changed in a certain interval of time. Okay? Let's say we have another journey. This time, we did not start recording the journey at the very beginning when the car was stationary. Let's say we started recording the journey. Okay, let's see. Let's say it started moving at t equals 0, and at t equals, let's say, 4 seconds, the car had a velocity of 2 meters per second. Let's say I'm recording the journey from this time to this time. So at t equals 2 seconds, at t equals 4 seconds, the car had a velocity of 2 meters per second, and at t equals 10 seconds, the car has a velocity of 10 meters per second. So how much velocity has increased in this time period? I would write that as my change in velocity. I use this triangle, which I call delta. It just represents change. So I'm just going to write change. We use this symbol to represent change in our formulas and calculations. It just makes it easier to write down things. Over change in time. So what is your change in velocity? How much velocity has increased? It went from 2 to 10, right? So the increase is of 8 meters per second. How can you find the increase? You can just subtract this 2 from the 8. An expanded form of the formula will be the final velocity, v final, minus the starting velocity, vs, okay? Divided by your ending time or your final time, t final, minus your ts, which is the starting time. So your final velocity was 10. Your starting velocity, or the velocity at which you started recording the journey, is 2. The final time is 10. And your starting time was 4. So you have 8 by 6 meters per second squared. That is your acceleration, okay? So acceleration is the change in velocity at a notable interval of time, okay? Here. Now, you can either learn the formula like this, delta v by delta t, or you can learn the expanded form, which is the final velocity minus your starting velocity divided by your final time minus your starting time. There's a few things here that would be important to remember. Let me see. Okay, let's do a question first, and then I'll touch upon a few things. Okay, Firstly, let's talk about the units in a bit more detail. So we know that acceleration is change in velocity divided by change in time. The unit for velocity, the numerator, is meters per second, and the unit for time is second. So here you have meters per second being divided by second. If I expanded that to make it more clear, it's meters per second. Let me color code it. This thing, meters per second, being divided by a second, which is the division symbol. I can use the pink color here, which is the division line, by second, which is the yellow color-coded symbol. So we know that when we change the division sign into multiplication sign, meters per second multiplied by, the preceding term or the term after the division sign is reciprocated or flipped. So it becomes 1 by s. Okay, so your ending unit, these 2 seconds are then multiplied. So you have m at the top and 2 seconds at the bottom. So second multiplied by second is second squared. So that's where your unit for acceleration comes from. It's meters per second squared. It's better to memorize these things to save time in the exam. But let's say you forgot something, you can always derive the units like that, okay? Now, let's look at another journey. So let's say this was your start point. This is at t equals 0, you started recording the journey. This is when you, or let's say t1 is the time when you started recording the journey, and t2 is the time when you stopped recording the journey. So you're basically recording the journey from this time to this time. Let's say that at t1, the velocity was 20 meters per second, and at t2, the velocity was 4 meters per second. So this is the final velocity, and this is your start velocity. And t1 is your start time. I'm going to just write ts here. Let's say it was 2 seconds. And t2 is your final time. I'm just going to write an f here as well. And let's say it was 6 seconds. Now, if I want to find my acceleration, I will use my formula delta v by delta t, which is final velocity minus the initial or start velocity divided by your final time minus your start time. Remember, the final comes first, okay? Final comes first. Learn with me. Final velocity minus the start velocity divided by final time minus the start time, okay? Final comes first. Now, your final velocity is 4 minus your start velocity is 20 divided by your final time is 6 seconds minus your start time is 2 seconds. What is 4 minus 20? It's negative 16. If you don't know the subtraction here, you can just subtract 4 from 20, you get 16. And the sign is of the bigger number, which is 20, okay? So 20 has a sign of negative, 4 has a positive sign, which is not written. So you get negative 16. And 6 by 4, 6 minus 2 is 4. So negative 16 by 4 is negative 4. 1 times 4, or 4 times 16, and the negative sign just comes along, and you get negative 4. And the unit is meters per second squared. Now, this negative sign tells you that the car is decelerating. So the car has its velocity decreasing over that interval. So when the car is slowing down over a time interval, we say that it's decelerating, okay? So another term is deceleration or negative acceleration. Or deceleration. Okay? Deceleration. All right. Hopefully, this is clear. You can also understand this concept by thinking of day-to-day life. When the driver applies force on the accelerator or gas, the car speeds up. The car accelerates over in a time interval. When the driver presses the brakes, the velocity or the speed decreases and the car decelerates. It slows down and eventually comes to a halt or a stop. Okay? Let's expand on the idea of acceleration and look at its categories. Now, I want you to remember two types of acceleration: uniform and non-uniform. The easiest way to remember it is that a uniform is same for everyone, right? If you have a uniform, whether it's at a school or, I don't know, a chess club. I don't think they have uniforms for a chess club. I don't know how that came to my mind. So for any formal thing, if you have a uniform, it's same for everyone. And another word for same is constant. So uniform acceleration is constant acceleration, constant. And non-uniform acceleration is variable or changing acceleration. Let's look at that in a bit more detail. I'm going to record two journeys here. Okay, so this is your journey A on the left side, and here's your journey B. T equals 0, 2, 4, 6, and 8. Let me replicate, oops, sorry. Let me replicate that here. Okay, so now at equal intervals of 2 seconds, I'm going to measure the velocity of two cars. Okay, let me draw a line to separate them. Here. So at 2 second intervals, I am going to see the velocity of two cars. For car A, let's say the velocity at t equals 0 was 2 meters per second. So time is in seconds, and here you have velocity in meters per second. Okay, so at 2 seconds, the velocity was 4 meters per second. At 4 seconds, the velocity was, or let me just change the numbers a bit. So at t equals 0, the velocity was 0. At t equals 2, the velocity was 1, and then 2, and then 3, and then 4. Now you see, after every 2 seconds, the velocity is increasing by 1, right? So it's increasing here by 1. So it's plus 1. That is the change in velocity. After the next 2 seconds, the velocity again increases by 1. Again, the velocity increases by 1. Again, the velocity increases by 1. So these numbers in yellow are your change in velocity. And what's the time here? The change in time is 2 seconds, right? Change in time, delta t, is 2 seconds. So I'm recording the velocity after every 2 seconds. So if I found out the acceleration in all of these intervals, like if I found out the acceleration in this interval, and then this interval, and then this interval, and finally at the fourth interval, let's see what we get. In the first interval, acceleration is change in velocity divided by time. So your change in velocity was your number in yellow, which was 1. And what's the time? 2. Next, for this one, your acceleration is change in velocity, it's 1, and your time is 2. For this one, you have, again, 1 by 2. For this one, you have 1 by 2. So you see, at all of these intervals, your acceleration is the same. It's a half. The car is accelerating at the rate of half meters per second squared. So this is constant acceleration. The car is accelerating at a constant rate. However, let's see the journey of car B. Let's say that car B had a velocity of 0 at time 0, and then it had a velocity of 1, and then it had a velocity of 5, then 8, and then 9. Now, you see, in the first 2 seconds, the car increased its velocity by 1, In the next 2 seconds, the velocity increased by 4. In the next 2 seconds, the velocity increased by 3. And in the next 2 seconds, the velocity increased by 1. So the change in velocity, which is in blue now, is different. So when you see that the change in velocity is different for an interval, which is of 2 seconds, then let's see what you get for acceleration. So I'm going to use the formula for change in acceleration, which is change in velocity divided by time. For the first one, second, third, for the first interval, for the second interval, third interval, and fourth interval. So the change in velocity for the first interval is 1, and the time interval is of 2 seconds, right? For the next one, you have a change of velocity of 4, and then the time interval is the same. We're recording the velocities after every 2 seconds. So for the next one, we have change in velocity of 3, and the time interval is 2. For the next one, we have the change in velocity of 1 and the time interval of 2. Now you see for all intervals, we have different changes in velocity. The first and the last one are the same, but it's not consistent. It's like different for intervals, right? When we have different accelerations in the same interval of time, we say that the acceleration is changing or it's non-uniform. Okay? In practical life, we usually have non-uniform acceleration. You would see that sometimes when you see an obstacle on the road, you would want to slow down. If the road's clear, you speed up, and you speed up at different rates. If there is nothing at all in front of you, you would speed up more. But if it's like a bumpy road, you would speed up sometimes, and then you'll slow down when it's a speed bump, or speed breaker. In that case, you will have changing acceleration. Okay? So let's recap all of what we've studied so far. We studied that a physical quantity is a quantity that can be measured. It has a magnitude, which tells you the size of the physical quantity. And it has an SI unit, which gives you more context into the type of physical quantity you're talking about. Next, we have two types of physical quantities. We have scalars and we have vectors. On the left side, I've written scalars. On the right side, I've written vectors. And we have distance and displacement. Distance is the total length from point A to B, and displacement is the shortest length from A to B in a straight line. Distance is always greater than if it's a curvy path, or equal to if it's a straight path, then displacement. If you have circular motion, displacement is 0, but distance is the total length. Okay? So remember, whenever you have your start point equal to the end point, or whenever your moving object returns to its original position, or whenever your moving object returns to the point where it started its journey, your displacement is 0. Now, if you divided that distance by time, you would get speed. If you divided the displacement by time, you will get velocity. If you divided velocity by time, you'll get acceleration. Okay? So the standard unit for speed is meters per second. For velocity, it's meters per second. For acceleration, it's meters per second squared. And then we have uniform and non-uniform acceleration. Uniform acceleration is constant acceleration, and non-uniform acceleration is changing acceleration. Lastly, let's do a question and we'll end the class. So let's say the velocity of a car increases from 4 meters per second to 10 meters per second in 3 seconds. Find its acceleration. So it increased from 4 to 10. Firstly, identify which one is the final velocity and which is the starting velocity. So the car started at 4 meters per second, so this is your starting velocity, and it has finally reached the velocity of 10 meters per second. And how much time did it take to reach that velocity? 3 seconds. So this is your time or change in time, and you have to find the acceleration. Let's directly use the formula for acceleration, which is change in velocity divided by time, or final velocity minus the starting velocity divided by how much time it took for the car to gain or increase that velocity. Your final velocity is 10, your starting velocity was 4, and you divide that by 3, you get 6 by 3 or 2. And what's the unit? Meters per second squared.